Hi all, in this video we are going to look at security best practices in web development. One thing we should always keep in mind is that security isn't just a feature but a fundamental requirement. And there can be very serious consequences for security breaches, such as the organization will have to bear huge costs and the organization will lose their customer reputation, and there can be legal consequences, so it can also be a threat to public safety. These are a few examples of security breaches. These are very serious cases, but I would not go into detail about them now because probably you have heard of at least some of these famous security breach examples. One thing to notice that there are different types of security breaches. They can be ransomware infections or breach of data privacy or even software supply chain attacks. So it is not just one aspect that we should focus on when we are implementing secure web applications, but there are many areas to consider. Uh, Now we look at the types of security threats. Malware are viruses, trojans, worms, and spyware. This malware, phishing, and denial of service, and social engineering, and man in the middle attacks are they are mostly covered in security or network courses, so I would not talk about them now, but I would like to talk briefly about SQL injection attacks. So these attacks inject malicious SQL code into input fields to manipulate a database, and potentially they would gain unauthorized access to the database, or they may extract sensitive data. In your project developments, you can easily implement your code to prevent these attacks. I will look at this later as well. Then cross-site scripting. This is a misnomer actually. The name has originated from an early version of the attack where stealing data cross-site was the primary focus. After that, it has extended to include injection for any content, but we still refer to this as cross-site scripting. Cross-site scripting is serious and can lead to account impersonation, observing user behavior, or loading external content, and stealing sensitive data, and much more. Zero-day exploits are attacks that target vulnerabilities in software even before you have had the chance to release a patch or an update. And then software supply chain attacks. This is something that I would like to highlight here because we mostly overlook this. We have to rely on third-party libraries, and most of the time we don't hesitate to add another library to our project if we can use some already available code without writing long and complex functions. But the downside of it is this code can come with vulnerabilities, and when exploited, the damage is much larger because all the downstream dependencies become vulnerable. So that you know that security is important and there are many types of threats, you should realize that security is something we should integrate throughout the entire software development lifecycle, and the earlier we apply security practices, the better. Next, we will look at some basic secure coding principles. First is input validation. Again, as you might know by now, Lack of input validation lead to cross-site scripting, SQL injection, and other attacks. The idea here is you should always validate the data from untrusted sources as early as possible. And the untrusted source does not have to be a web clients over the internet. It can be backend feeds over extranets as well. You can validate input syntactically or semantically. Syntactical validating is enforcing correct syntax, such as date or digit, as in this example here. Semantic validation is enforcing the correctness of their values, such as validating the end date and start date. Well, next we have authentication. Authentication is verifying that an individual or a website is whom it claims to be. There are some best practices you should follow when implementing authentication functions. You can enforce proper password strength controls like minimum length and periodic change of passwords. Also, store passwords securely and implementing a secure password recovery method. So you can follow these best practices to ensure that you have proper authentication mechanisms. And another thing is proper authentication error message handling is also important, because otherwise if your error message include any internal status which you should not show to an outsider, they can exploit it. So for an example, in this given code, depending on the implementation, the processing time can be significantly different according to the case, success or failure. And this allows an attacker to mount a time-based attack. So you can clearly see that if the user does not exist, the application will directly throw an error. But on the other hand, when the user exists but the password doesn't, there will be more processing before the error is thrown. So the response time will be different for the same error, and now the attacker will be able to identify the difference between a wrong username and a wrong password. The second code will go through the same process no matter what the user or the password is. So the application will return in approximately the same response time. The problem with returning a generic error message for the user is that it can be a bad user experience. This is a trade-off that you have to make, and you should decide on the use case of your application, which is the most critical factor for you. Next, we will look at authorization. Authorization is verifying that a requested action or service is approved for a specific user or some other entity. Don't confuse this with authentication. They are two different concepts. Some points to follow are always try to enforce the least privileges and deny by default. We talk about a least we will talk about least privileges in the next slide. Another good practice is to validate permissions on every request. Also, it is better to prefer attribute-based or relationship-based access control over role-based access control. It basically means rather than access controlling only based on the role, we can do it granularly based on the attributes or the relationships between resources. Least privilege is assigning users only the minimum privileges necessary to complete their job. Although maybe this is most commonly applied in system administration, This has relevance to software development as well. Um, a failure to give least privilege can threaten the confidentiality of sensitive information in your application. During the design phase, ensure you correctly define the boundaries of resources and operations performed on them. Add tests to validate the defined permissions. And remember, it is easier to grant users additional permissions rather than to take away some they have previously enjoyed. Next, we will look at SQL injection vulnerability. This is also something I think you probably have learned before, and I mentioned about this in a previous slide as well. So these attacks can happen when you create dynamic database queries using string concatenation, which also includes some user input. In this example, we are not validating the username and it is simply appended to the query. So now an attacker can inject any SQL code they want as user input. One way of overcoming these attacks is by using prepared statements. There are language specific prepared statements. In this example, you can see Java and Python prepared statements. Next, we have another important topic, data security. So there are these best practices of ensuring data privacy, like secure data storage, secure data transmission, masking sensitive data, and proper access control. As you may know, most international software companies have to follow data compliance regulations such as GDPR, which is for countries in the EU region, and other regulations such as US data privacy laws. There will be severe consequences if those regulations are violated. For example, for a violation of GDPR regulations, there can be a fine up to 20 million euros or 4% of the business's total annual worldwide turnover. Most of the organizations have strict policies to ensure that the customer data is protected. But a small mistake during development is enough to cause a data leak. For example, sometimes we do not pay much attention to log messages, and for easier debugging, we might include customer names in the log messages, such as cannot find the user details of the user ABC. Then the customer names can be sensitive information, and this can be a violation of GDPR. So we have to be very careful when dealing with data because data leaks can happen at any time. Secure APIs. These are some best practices that you can follow to ensure secure APIs. Use rate limiting. You can throttle users to stop them from abusing your APIs and making a denial of service attacks. And like we have talked before, validate the inputs. Also try to use a token based authentication or API keys because they enhance security. Tokens have more granular permissions. They are valid for a limited time, so when the token expires, the user has to generate a new one. Tokens also support a single sign-on. Single sign-on is allowing users to log in once and access multiple services without needing to authenticate separately for each one. So tokens are more secure than API keys, but API keys are faster and are anyway better than traditional authentication methods like the authentication methods based on username and passwords. Next, we will look at secure development tools. Static application security testing tools. They analyze source code, bytecode, or binary code to find security vulnerabilities or coding errors without executing the application. And dynamic application security testing tools test running applications for security applications. So what they do is they imitate the attacks and check the application responses. So they help discover runtime issues. Interactive application security testing tools are kind of like a combination of static application and dynamic application security testing tools. So these interactive application security testing tools can offer real-time feedback during runtime, and then software composition analysis tools scan open source and third-party libraries to identify known vulnerabilities and licensing issues. Then container security scanning tools. They monitor the security of container images to identify vulnerabilities. Web application firewalls protect web applications from various attacks like SQL injection cross-site scripting. Then there are security testing frameworks and code review tools, and uh, these tools like analyze log data from different sources to detect and respond to security incidents and anomalies in real time. There are also authentication and authorization libraries. You can use them instead of implementing your own authentication and authorization functions. Then you probably have heard about security linters. They are code analysis tools that automatically check code to see whether they follow secure coding standards, best practices, and if they have any potential vulnerability. I would strongly suggest you to add and enable linters in your project because you can also learn the best coding practices from them. Even though you might feel like warnings are annoying at first, they will make your life easier in the long term. Next, we are going to look at security testing. There are different types of tests to evaluate applications for vulnerabilities, weaknesses, and potential security risks. Vulnerability assessment involves scanning the application to identify weaknesses such as outdated software, misconfigurations, and unpatched vulnerabilities. Penetration testing or pen testing is done by skilled testers. They simulate real world attacks to identify vulnerabilities that might not have been discovered through automated scans. Then there is security scanning, network security testing, cloud security testing, and uh, compliance testing and security code review. So fast testing. In here, what we do is we attack an application with a large volume of unexpected and malformed data to identify vulnerabilities like buffer overflows and input validation issues. uh, Incident response. So incident response is an organized approach to manage and mitigate the consequences of security incidents like data breaches or other events that could impact an organization. Um, Here, different organizations may have different ways of handling an incident, but having a proper incident response plan can mitigate the damages, which otherwise would cause great losses. Security in open source software is also an important topic. Like I have mentioned before, this is sometimes overlooked, but open source is not inherently more secure than proprietary software. But it has the potential to be more secure. But on the other hand, because of dependency chains and widespread adoption, a vulnerability in one open source project can end up being a vulnerability in thousands of applications. Therefore, it is important to manage the third party libraries in your projects properly. Don't keep unused libraries because functionally there are no errors in keeping unused libraries in our projects. We tend to just ignore the additional dependencies, but do not do that. And always check for dependency updates. Check for vulnerabilities in the dependencies. You can configure bots like Dependabot or InnovateBot to automatically track these updates to dependencies. Um, there are these secure communities like OWASP dedicated to improving OSS security, that is open source software security. So this organization focuses specifically on web application security. They have resources such as guidelines, best practices, and tools to help developers and organizations to build and maintain a secure web applications. And if you like to learn more about web application security, a really good resource is this Open Web Application Security project cheat sheets. So you can search and have a look at that. And then CVE, or Common Vulnerability and Exposures, is a program that assigns unique identifiers to publicly known security vulnerabilities. These IDs are used to track and reference vulnerabilities across the security community. Then, as for the conclusion of this presentation, security is a main requirement in web development, and it is not just a feature. If you do not follow the best practices to ensure security, there can be serious negative consequences. Even though we try to follow all the best practices, we make mistakes, and therefore it is important that we use secure development tools to monitor vulnerabilities in our application. In your projects as well, try to use linters. They can be pretty useful. And security testing and proper incident management is also important. And finally, we talked about open software security and like why it is really important to consider the security in open source software as well. And this is the end of the video, and thank you for watching.